Thanks.
Ben.
Is this thing on? Hello?
Am I live here? All right. Cool. First of all, thanks to all the ShakaCon organizers, people, VIPs make this happen. Let's give them some. Thank you, guys. All right. So as you see, it's suns out, guns out time, and
we couldn't decide who changed.
Yeah,
it.
we were gonna.
Both him.
We both wanted to be C-Tates, and there was no Jonah Hill in the group. So here's what you get. Charlie, Chris. Charlie works at Twitter. I work at IOActive. We're going to talk today about car hacking stuff, obviously, but really, when we first started the project, we wanted to lower the barrier of entry so more people could do it. And we realized that cars are still really expensive, so we need other ways to get our community involved in this stuff.
Right. So when we did our original research like 2 years ago, we showed that if you plugged into a car, you could control things like steering, braking, and stuff like that. And one of the things we did was we wanted to make sure we released all our tools because we wanted to get everyone kind of involved in car hacking. And we thought there would be this huge sort of revolution of people using our tools and hacking cars, and it didn't happen. Yep. And so we're like, what went wrong? And I was like, well, I think what went wrong is we had cars and other people didn't want to like wreck their cars. Yeah. And so this whole talk is basically like how you can do our research without having to buy and possibly wreck a car.
Exactly. So we hope it inspires people to do some more car hacking work. If you think about car hacking, most people think about it in the sense where it's a remote attack, right? You attack it over Bluetooth somehow, or over the cell network, or you somehow get control over tire pressure sensors, things like that, right? And that is an integral step if you're hacking a car remotely, but it's not the only way you can do it, right? There's these little devices that you can program and stick into a car's diagnostic port, and you can send any messages you want.
And as a teaser at Black Hat and DEF CON this year, we're going to show how to do the remote part.
Yeah, see, everyone's in on the secret. We're going to show you how to do this part, which is fairly complicated. But if you want physical control of the vehicle, right, you want to control things like steering, braking, acceleration, windshield wipers. At this point, you're going to send CAN messages, and you have to inject them into the bus. So just compromising the remote piece doesn't really give you access to this, right? Additionally, there's gateways involved sometimes, too. So you have to be able to, say, go past, we'll call it like a router, right? You're going to send these messages out, but there may be some limitations. It's a multi-stage process to do all this stuff, and many times certain portions of the stages can be done without the actual car. And again, that's what we're going to try to talk about today, how you can look at individual devices in case you want to figure out things like how you would perform a steering attack or braking attack or alter the display, but you don't want to buy a vehicle just for that instance.
All right, so in a real attack, step one, you get code running somehow, either locally or remotely. Step two is you want to start sending messages out from the compromised ECU, the little computer, to other ECUs. And then you, like Chris said, you may have to hop over different sort of barriers in your way, even in that network. And so we're going to just show you how you can get these ECUs, not in a car, and get them to work, and you can figure out if there's remote attacks, figure out how to send messages and that sort of stuff.
Yeah. Why is that? Car hacking is hard. Let's go shopping, right? So these are the receipts, if you saw the videos of us with the Ford Escape and the Toyota Prius. So the Ford was 20,000 USD about. The Prius was 31,000. So right now we're talking about at least a $50,000 endeavor. And that doesn't include other things, like you have to insure these cars, which was amazingly easy. I don't know if they know what we're doing with them, but we still had to insure them.
Well, we never made a claim.
Yeah, there's never any claims, which is great.
I crashed my car into my garage, didn't call my insurance company.
No. We blew up the inverter of the Prius, right? Like that cost like $5,000. We had to get the car towed. You have to register these vehicles because where else are you going to test them other than roads, right? So there's a lot of costs associated with this.
Yeah, so I mean, like when people do computer security research normally, there's an expectation you're going to have to buy some stuff. So like you have a laptop, and you probably buy a copy of IDAPRO or something, right? And so everyone's sort of willing to spend maybe a couple grand on research, but cars were costing $50,000 or $30,000 or $40,000. People didn't seem to want to spend that. We got our cars through a DARPA grant, so we wouldn't have probably bought cars
Yeah.
either. And so the idea of this research is, can we, like, we're not going to be able to get car hacking down to the $2,000 range, but can we at least get it to, like, 3 or 4 or 5,000 to where people might be willing to spend that?
Yeah. So, right, lower the cost. Cars are really expensive. If you already have one, you probably don't want to do what we did to ours because you could somehow break them. It costs a lot. Also, you want to look at pieces of the car in an isolated environment, right? You would like to see what messages the power steering module does, what messages it receives, what it sends, and then you could identify these instead of looking them in a big, packet capture.
Right. So like he's pointing out, and if you just sniff the messages between the ECUs, you don't know which ECU sent which message and who it was intending it for. It's just a ton of messages. And one of the ways that we used in the past to figure out, who sent which ECU or who sent which messages, we would just unplug one of them and see which messages went away, or we would cut one or something. And so, to find out this stuff, a lot of the things you have to do is kind of destructive, and people don't want to do that.
Yeah. So, what we wanted to do was develop a platform where we're going to show you how to, get these things running outside of a vehicle, isolate them, look at the messages, send messages. So you can do this testing with, a couple $1,000 instead of tens of thousands of dollars.
And you don't mind if you wreck something.
Yeah,
If you're wrecking a little thing that costs $500 instead of your car. Which
exactly. Everyone's bricked a phone who's done phone research before, right? So you can afford to get a new one, or whoever you work for will buy you a new one.
Because I'm really good.
Yeah, Charlie hasn't because he's perfect, always.
Accepting cars.
Yeah, accepting cars. There is some prerequisites. I don't think either of us claim to be hardware hacker guys by any means. We leave that to the Joe Grands of the world. But you do need some, basic electronics knowledge, grounds, powers, use of a multimeter, stuff like that. Knowing about CAN, how cars work and how they communicate, very useful, probably required. And then generally things like wiring diagrams, right?
Right. And also, if you're interested in this stuff, we have a whole paper that's 100 pages full of all this information. This is just sort of an overview.
Yeah. I guess we have to go fast. But yeah, we have all the tools and the paper and all the code and stuff we wrote that we put out there for free. You guys go download it, use it, whatever. Hopefully it saves everyone time and kind of gets you started on this. So I think one of the hardest parts for us, automotive disassembly was really hard because we were getting ECUs out of the car, and we are not mechanics by any means.
We didn't have the right tools or anything.
Yeah, so we just used crowbars and hammers to completely destroy these cars. Again, you're probably not going to want to do that, but
yeah. If you look back at some of the pictures of the cars when we were doing the research years ago, people were like, "How come you have the dashboard ripped out?" And it's like, "Do you have to do that to do the things to the cars?" No, that's this project that no one knew about.
So yeah, when you saw the videos and the Prius was ripped to shreds, it wasn't because we needed to do that to physically control it. It was we were actually working on this second project while finishing up the first one.
Right, which required destroying stuff.
You got the CAN stuff, buddy.
Oh, great. Okay, so what is CAN? CAN is essentially the protocol that the ECUs talk to each other most frequently in cars. And the things you need to know basically is it's 2-wire, and that's it. So,
and they're terminated by 220 ohm resistors. So basically it's just twisted wires, as you see right there.
And
super simple.
Right, and so if you don't want to have a car, you want to have something on your desk, you need to create this CAN bus, this CAN network that the different ECUs can talk to. And this is basically what it looks like. Yeah. So you have the 2 resistors, and then there's going to be CAN high and CAN low going between them. Yeah.
So that's your minimal CAN network there, right? Just simple breadboard, resistors, wires, and that's basically essentially what a car's network is.
Right. So then this is the next step up in difficulty. So here I think it's an ECU plugged into the CAN network, and then the ECOM cable, which is the thing that we used in our previous research to read and write CAN messages. So here you can turn on the ECU. You can use the ECOM cable to read the traffic to see that it's working properly.
And we released all the code and stuff for the ECOM cable and Python scripts and everything and all the Python bindings. So you can buy one of these cables for $100, cut them up, make it yourself. We give you all the instructions, and then you can go about sniffing and doing all this stuff. So there's no reason to recreate the wheel. We really already did.
So yeah, so it's at its most basic level. If you hook this up, you can begin to read and write CAN messages without buying a car or messing your car up. Yep. So this setup probably costs like a couple $100 or something.
Couple $100, yeah, easy breezy, right? As we said before, these ECUs, generally speaking, They have a lot of pinouts, but you're really concerned with your powers, your grounds, CAN high and CAN low. Many times they have more than one CAN interface, so there'll be multiple CAN highs and multiple CAN lows. And you really, the best thing to do is go get a mechanics account where whatever ECU you're looking at. For example, we were looking at a Toyota, so we had a Toyota mechanics account and a Ford mechanics account. And we could actually look at the wiring diagrams and you could identify the pins. It's pretty, if we can do it, I'm pretty sure anyone can do it.
Yeah, it's not hard. So when you get your wiring diagram from the mechanics account, it looks something like this. And so there'll be a little picture and it'll look just like the ECU. And you can see the pins and which go where. And then, like I said, you have to hook up the power, hook up the ground, hook up the ones for CAN high, CAN low, and try it out and see if you read messages. Sometimes it'll just work from that. Sometimes there's like 50 other pins, and unless you have those hooked up to something, they don't quite work.
Yeah, exactly.
We'll get more on that.
This is essentially a super simple one. This was the seatbelt ECU for the Toyota Prius. You also got really nice diagrams like that. So if you went and looked at the ECU in the car, you could actually color code them. So you could see where they went, right? Because these are the same color wires they use in the vehicle. You don't always have that, privilege to have a car, but generally speaking, the wiring diagrams are enough to get you started, have this thing boot up outside of the vehicle.
So we talked earlier about one of the first things you want to try to figure out is what messages each ECU sends, because then you can figure out, like, if you're interested in, say, braking, you'll want to know, and there's some collision prevention system. You want to know that whatever sensor is sending the messages, that's going to be the message that has to do with braking.
Yeah.
So if you can figure that out, then you went from 1,000 messages that might be it to 5 messages that you have to investigate.
Yeah, so the first time around, we did it the super hard way. We wanted to find out about steering. We'd go outside with our sniffer, parallel park the car 500 times like a psychopath in front of your neighbor's house, and you're looking at your sniffer and trying to figure out these messages, and it just took forever.
Right, and it didn't work very well.
No, it didn't work very well.
So
we weren't very smart about it.
Right, so then we had the idea that, well, why don't we somehow isolate one ECU by either cutting it or putting something in between it to sort of monitor the traffic going to and from it. And that's what this all.
Charlie was more cavalier than me. He would just go start cutting wires, and I was like, no way, I'm not doing that.
And, for some things, I definitely didn't care, like the parking assist module, right? It's like, well, if that thing breaks while I'm driving, who cares?
Yeah.
Well, like at one point, I was doing it to the engine.
Yeah, that was bad.
You pick up your hood, and there was just this like mass of wires all taped together.
He's like, just cut them. I was like, no, the car's going to be a brick. So
no, it worked, but it was like if you hit a bump, I would imagine the engine would just stop.
Anyway, you want to isolate these things. That's the easiest way to go about it, but you don't want to cut all the wires, right? Or if you're willing to cut a few wires.
So yes, this is the general idea, is all the messages normally are just broadcast, and so you can't really isolate one from the rest of the traffic. So what we did was we were going to build a bridge between a single ECU and all the other ECUs, and then just sort of ferry messages back and forth between the two networks. Yeah. And then we could see which ones were going which way.
It basically works like your home router, right? It routes messages back and forth. And for us, we did something like this. Again, the seatbelt ECU, it's pretty easy. We cut CAN high and CAN low, hooked it up to our ECOM cables. We had 2 of them. Figure input, output. They both came in. They go back and forth. And I think we have a little video here that shows you exactly.
Okay, so
right.
We
can
have
hear me
the
talk.
Toyota Prius
I passed, Chris.
with the CAN bridge hooked up, but not powered on right now.
CAN.
There's no blinking lights, which means the bridge isn't running. So if we turn the car on, there's no communication between the Prius and the seatbelt ECU. And you'll see shortly that it says check PCS system. That means check the pre-collision system, because the ECU down there is not communicating. So if we turn the car off and then start our CAN bridge, it's now working on both of those ECOM cables. They're blinking right now. Then turn the car back on. We'll see that the Prius is turned on. And if we wait for the same amount of time before, we won't see any check PCS error. That's because the traffic from the CAN bus, which is that little plug there, is going to ECOM cable, going to the PC. The PC is going to the ECOM cable, and to the ECU.
Alright. So the point is that now when we've done that, we can see which messages the seatbelt ECU is sending out, and we can also start to eliminate messages going to the seatbelt ECU to see which ones it requires to operate.
Yeah. And it was a pretty effective method for isolating one unit and seeing what it sends out and what it gets in. But again, right, we had to cut wires, you had to have a car.
You saw his dash was not in like
Yeah.
super great condition in that case. So
Yeah, you
still
don't want to
probably
rip
not what you
your
wanna
glove
do.
compartment out and cut a bunch of wires, right? Most people don't want to do that. So what was our solution for this? And as we've told you already before, the Workbench.
Right. So then the idea is instead of cutting wires in cars, we'll just buy another seatbelt ECU, put it in our Workbench, wire up a fake CAN network, and then do it from there.
Yeah. And as you probably saw from pictures before, it looks like this, right? You find your ground, power, CAN high, CAN low. You hook up your stuff. Some of them require additional hookups, whether they're seatbelt motors or gauge wires, things like that. How do you tell if it's working?
That's a Prius one. You can do that one.
Yeah.
ECUs,
This
the
one's
ones that show you something.
Oh, man, I gotta fast forward this. I don't know how to do it. Anyway, the easiest way to see messing with ECUs that have a visual, right? If it turns on, well then you at least have the power and ground right? Unfortunately, what are you doing here?
I was trying to fast forward it.
Exactly.
On my Mac, it's super easy.
Yeah, not on this. Unfortunately, not every ECU, actually a very limited amount of ECUs have any type of visual indicator, right? Telematic systems are awesome because you turn it on, you can see it booting up, and you see a screen. But other ones don't work like that.
Is this a movie?
Yeah.
Okay, we've got the
All right. So here is, I think it's parking assist module. I could listen
Yeah.
to myself, but I don't like to.
Yeah.
to it. Got our ECOM cable hooked up to it, and we're gonna see if we see any traffic.
So here we're just going to
Start
sniff to
looking
see
at
if the thing is
traffic.
actually generating
So
traffic.
we're gonna power on the ECU, and there's the traffic.
So we know it's at least on. That's sort of the equivalent of the screen coming on for the radio.
So basically, you hook it up, you have your sniffer running, you turn it on. If you see some traffic, at least the thing's running, right? Like it at least proves that it's up and running because you can't hear them, and you have nothing to see.
Right. But sometimes just because it's emitting traffic doesn't mean it's fully functional.
Yeah. As you'll see many times, we had this trial and tribulation where you would see the messages that you thought you would see, but the values would be different than what we saw them in the car. Luckily, we could compare them, right? Because we had the car and we had the ECU. And we realized that they would send different messages out because they weren't right. This is the seatbelt ECU here. And the one on the left is in the car. You see the first two messages are the same, and then they start to differ, right? The one on the left, one at 0, that's saying, yeah, we're all good. Everything's good. I'm hearing everything I need to hear. We have all the systems going. The one on the right that was just the ECU on the bench is sending out 1, which I assume is like, hey, I don't know what's going on. The pre-collision system isn't going to work for you, right? So you're going to have these isolation difficulties that are, it doesn't know what to do because it's not getting all the signals.
Right. And so that might mean it doesn't have a sensor it needs or it doesn't see traffic it expects. You don't necessarily know. We just know that it's not working properly. You wouldn't expect to be able to do security testing on this ECU right now.
Yeah. Well, how do you fix that? Start attaching the sensors and actuators needed. Again, we had a car, so we could start ripping out seatbelt motors and speedometers and things like that. So even if you don't have those pieces accessible to you, you can fake it, right?
See how
Right. So
the
sometimes
oil-
you don't want to necessarily rip out a whole sensor for, in this case, it's oil pressure or something. Like because that's like another $100 and
Yeah.
you
You're
have
on
to
a
figure out how it
limited budget.
works, right?
Go to the oil
So, but you can look in the manual and see what it expects. And it turns out that the oil sensor expected that if it received on a certain sensor that it was at ground, then it was okay. Otherwise, it wasn't. So
ground right now.
let's see. So if you notice, I plug it in, then the sensor comes on. I think. Wait.
Yeah, at one point.
There
There we
it comes
go.
on.
There we go,
So anyway,
the oil.
so you can just fake it, and the speedometer thing will think everything's fine.
And most of the mechanics accounts, this is exactly what they're designed for. They're going to tell you the expected values of these things. Like
Right.
it should be above or below this resistance level, right? So you should be able to fake most things.
Yeah, because people bring their car into the mechanic and they say, hey, my check oil light's on, but I have oil or whatever. And then they're like, oh, they get out the manual and it says, oh, it should be between these values. They can measure and be like, oh, it's not.
Yeah.
It must be the sensor.
Exactly. And you can do the same thing. Well, you can hook up a lot of sensors, right? And most of the ECUs in a car require quite a few things to actually, continue working. But CAN networks are designed to communicate, and you need other messages coming in and out.
Right. The whole point of the network is that all the ECUs are talking to each other constantly. And most of the ECUs, if they're not getting the messages they expect from other ECUs, they just shut down. They're like, I don't know what's going on. Something's messed up.
Yeah.
And so the way we dealt with that is we would just take a capture of messages and then replay it, and then the ECUs would think they were in the car.
I called it CAN Simulator 3000. It's going to sound really silly in 3001 when they're still using it.
It's going to be super retro.
I know, it'll be the retro simulator. Basically, that's literally it, right? It takes a capture from a vehicle and continuously replays it on a car. And most of the times, if you're just idling, that traffic is good enough to do some security testing because it's getting all the messages it wants. Again, it still requires a car, but at least you can go, say, rent a car, borrow a car, make a capture that can't hurt the car at all because it's passive, and then
so we have our
there we
phase
go.
3 set up
And then replay it on your miniature CAN network on your Workbench, and the ECU will actually think it's in the car, right? Because you have the sensors hooked up, or you're faking them, and it's receiving all the CAN traffic. Again, it's not a perfect solution, but it's definitely a cheaper solution than buying a car. You can, go grab a zip car for the day, capture traffic for an hour, return it, you're good.
Borrow a friend's car.
Or a friend's car, or steal one. I don't care.
So in this video, he's got you can see the actual seatbelt motors, which are these huge things, and we replace those with little tiny, like $3 motors from Radio Shack.
Yeah.
And so he's going to run the attack that would make the seatbelt motor turn on, and it'll make these little motors turn on.
Yeah. And you'll see, then I can say, hey, you're about to be in a collision. First tighten up the driver's, and then the passenger side, little motor spinning. As you see, even these little motors turn around. We use them because the first time I did this, I did it with the real seatbelt motors, and I was like holding the belts, and I almost ripped my finger off because they're pretty aggressive. They're made to save your life, not mess around in your Workbench. So be careful. Sending messages.
Let's see here. So this is basically the same thing for the speedometer. So when I turn it on, it's without it getting any CAN messages. You can see there's tons of error lights. It knows there's all sorts of problems. You probably couldn't do the kinds of testing you would want to do normally. But then in a second here, I'm going to start sending CAN messages. You see a lot of the lights went off, which means it doesn't notice there's error conditions. This particular unit is on 2 CAN networks, and so I only sent the messages for one. Now I'm going to send the messages for the second one. Now all the error messages are off. It thinks it's in the car. Everything is fine. You could do testing against it now.
Yeah. So essentially, right, if you have the right messages, you can do this type of testing on actual units. Oh, yeah. Is it the power steering one?
Yeah, this one's kind of interesting, except it's sideways.
It'll fix itself.
Will it?
Maybe.
Let's see. Is it playing?
There we go.
Oh, yeah. So anyway, here I'm in the car, and I have the power steering unit. It's like disconnected. And so there was no power steering before, but now once I send it messages, it's happy, and so then the power steering works. Yeah. And the only reason I did this one in the car is because on the Workbench you can't tell if the power steering's on or off, but in the car you can. It's like you can tell.
Yeah, you can't actually turn it, right? You can turn the steering column when you're outside the bench because there's no wheels connected to it on the ground. Right. What does all this look like? So this basically is my car in the box that I had for the Prius. There's just a mess of wires. But it has like a pre-collision system. The radar's in the front. I have my steering column out there on the brick. The seatbelt motors, power steering unit. So you can get all these things out of the car. And we realize that you have to.
You don't have to get them out of a car. You can just order them from
order
eBay
them online.
Yeah,
or whatever.
From the dealer.
And then, once you get them talking, you realize you need less synthetic traffic, right? Your simulator, your capture for your simulator starts shrinking because you have all these computers that are actually sending the real messages.
Right. So that when you have just one ECU plugged in and you're faking the network, you have to send the messages for all the other ECUs. But as you plug in more and more actual real ECUs, you have to simulate less and less traffic.
Yeah.
So it gets easier as you go.
And this is basically what your CAN bus starts looking like when you have 7 or 8 ECUs. It's just a mess of wires. I'm sure we could have done it better. But wires going to wire.
Done it worse, actually.
yeah, exactly. So, if you saw any of the videos, you've seen that we did certain attacks. And one of the attacks that we did that was pretty simplistic is you change the speed of the vehicle, right? You can tell the car it's going 100 or if it's going 0, whatever. It doesn't matter. This only works in the car because you can just send a message and everything's required, but you can't just pull the speedometer out and do the same attack. Like Charlie showed you before, it needs to be receiving the messages required.
Turn all this on.
And you can turn it on.
The instrument cluster starts up, but
There we
doesn't
go.
tell us the speed.
Yeah.
And
So you
it's
see,
all
mine's
lit
not
up.
getting any of the messages. It basically has no clue
Now
what's going on.
we'll start
Um,
simulating our traffic.
Exactly. You can simulate traffic
And
now, right? And we have all the other ECUs hooked up.
Back on.
Everything's
See
cool
the
now. It
clock
thinks it's
speed.
going 0.
Most of the lights are
Which it
going,
is.
the other ones
Yeah,
are
which it is. This car on the bench is absolutely going 0 miles an hour. And
And
I
we can
think
even do
I change it
things
to
like
like 20 or something like that, right? So you can,
we
so
can do all the testing that we
this
did
is just
before.
proof that if you get all this stuff out and you have a real minimal capture, that you can do the same types of attacks we did in the videos, but at home.
Right. So you could have verified that the things we had in our first paper were true, just without the stuff on the bench.
Yeah.
Or you could test it here and then take it to a real car and see that it would still set the
Exactly.
speedometer of the real
Yeah.
car.
Testing things like that, outside of the vehicle, potentially could be safer.
So here's the same thing, setting the speed and the RPMs on the Ford on a bench. So same deal. You can just do it. Same exact attack would work in a real car.
Yeah. The ones we found even more novel were things like
now we can
testing
also
steering, right?
test
Because this is essentially pretty dangerous if you're doing it in the car, especially on a road, right? You're doing a steering attack, someone's driving, say you do it at the wrong time, and they almost clip the back of a tractor trailer, something like that.
Which we've done.
Which we've done.
We haven't
Yeah.
clipped the trailer, but we've certainly put ourselves in situations we wished we wouldn't have.
So you can perform these types of attacks when you're testing steering. You'll see my vice grips there, twisting, and we're doing a steering attack. Again, a little bit safer, but you can verify that the attack works.
You can also sort of refine things like the timing of sending the messages and exactly how, if you have the checksum right. So you can do a lot of work in here that you don't have to do out in the car where it's dangerous, it's hot.
Yeah, we both live in cold weather climates in the winter, and the worst part was you're in the winter, you're in there, your hoodie hunched over your laptop. It sucked. Like you're out there for 4 hours, in the middle of winter. It's much nicer to do it in your house where you have heat and a workbench.
So here's the same thing with the Ford. With the Ford, we did the steering as well. And this is the same thing.
Yeah.
So you saw the thing just barely move. And the beep, beep, beep is the sensors. It has, it thinks it's
Backup
going to
sensor,
back up
yeah.
into something, but obviously it's in my house. It's not going to. But that's what that beeping is. So here's that same thing. Now it's,
Oh dear God, there's a child.
oh, there's a child I'm about to run over. So I'm showing that the rear sensors work outside of a car. You'll see what this thing is actually in a second. So you hear it beeping. It's sensing something, and it really is a kid.
I asked Charlie how he tested his backup sensor, and he was like, "Oh, I just had my kid stand behind me." I was like, "Trash can, cone, nothing." Like, nah, that's what kids are for.
All
All right.
I mean, see, the trash can can't get out of the way if things
Yeah.
go wrong. The kid can dive out of the way. It's super safe that way. No problems that he's not going to wreck my test vehicle.
You can make a new kid, can't make a new trash can.
I can't. I can make a kid.
I mean,
but-
you can, yeah.
Right. So then, if you want to see some more like sensors in action, so this is it's sort of a long video, so I'll show you. So the little black thing is a sensor that is in your wheel, and the like thing that looks like a silver gear is on the tire. And so as you drive, it turns around in a circle, and it can sense that. And so here is CAN messages, and you can see once I zoom in here a little bit. There's 4 sensors, one for each wheel, I should say. And I'm just going to show that as I spin that thing, one of them changes, which shows that the sensor's working properly. And I don't have to be in a car to do it.
Yeah,
so
okay.
you see the first number is moving. That's because I'm over there spinning the little silver thing next to the black
Again,
sensor.
you can isolate, individual bytes, right? Oh, this is front tire left, this is front tire right. So you can, again, isolate all these things if you're interested in those portions of it. Don't worry, this works, yeah.
All right, and then here is just showing you that you can, so infotainment systems are where you can do like remote attacks and Bluetooth and stuff, and you would want to maybe test that out in your house, not have your car running all the time. And here I'm just showing like the radio's working, it has like AM, FM, XM, Sirius, satellite radio. And so everything you would want, it has Bluetooth. So you can do all the testing you would want to do just in your house.
Yeah, I think this is one of the most applicable methods for this type of research, right? Because most people are interested in remote attacks, but again, that requires buying a car and doing all this stuff. You can easily get these infotainment systems for any vehicle you want. $1,300 or below is generally been the number we've seen. And you can do all your Bluetooth testing. You can do all your wireless testing.
So like we wanted to do
bench.
fuzzing against Bluetooth, and the previous researchers from academia did the same thing, and they would keep a car running for like 2 days. And that, like they would have the
Killing the planet is what they were doing.
right, and the university police would come by and hassle them and
Yeah.
stuff. And so, but this is like a better solution.
Yeah.
Here's another attack that we did. If you remember our previous, one of the scariest things we did was we could make the brakes not work in the escape. And the way this worked was you could bleed the brakes while you're driving, which you're not supposed to do apparently. And when you do that, then the brake pedal doesn't work anymore. And so if you want to test something like that without being in the car and making Chris do it, you can do the attack here on the bench. But the way, obviously you're not going to know that it's really doing it, but if you look, you can hear a noise. And it's actually like spitting out all this
Hemorrhaging
oil
brake.
all over all my equipment, which I didn't actually know was going to do that.
Yeah,
But it does. So I know it's doing something. So I know this message that I sent is doing something in the brakes. I don't know what it's doing at this point. I really do. But you can imagine I wouldn't know. And I would have to get in a real car and see what was going on.
Again, this is like one of the more dangerous ones. That's how he wrecked through his garage. That's how maybe
I wrecked you into
you wrecked me off the road. So this is pretty dangerous attack to do, even if you're like you know what's happening. So again, doing it on a Workbench, validating that it works without endangering anyone, probably the way to go.
Yeah, if you listen to that video with the sound way up, you can hear me freaking out because it's
Like
spitting
brake
oil
fluid
all
is
over
spitting
my
all over
stuff.
his garage.
Yeah. So then, like the stuff you can get simulated so well that even the official mechanics tools from the manufacturers work on your test bench. So here is the Ford mechanics tool against the bench. See, I'm not in a car. I'm in my room. And you can, if you look really closely on this thing on the right, there's like 5 squares. It's the volume of the infotainment system. So it says 4 right now. And then I'm going to just start playing with the knob, and you'll see that the mechanics tool is really plugged in. It really believes it's plugged into a car. And you can see that value is changing because I'm changing.
Again, mechanics tools are relatively cheap. You get a mechanics account, tools, couple $100, maybe $1,000, and you get these things, and then you can perform there's things called active tests. And that's how we figured out these messages. There's a mechanics tool, and it's like bleed the brakes. We have our sniffer running. We can see what the message is and replicate it.
Right. But if you just plug in your mechanics tool and you don't have the fake bench set up very well, it'll be like, no, there's a problem. I can't connect or something.
Yeah, this isn't a car at all.
Right. I don't know what this is. But yeah, so you can fool even the mechanics tools.
Yeah. So the pros of the bench, we said, is you get all these messages. You can isolate things. You can do mechanics diagnostics, attacks, remote research for sure. All without a car, right? This is just parts you're buying, eBay, call your salvage yard, whoever. But it's not perfect, right?
Right. So we mentioned you might need a car for a limited time to at least get a packet capture. Also, like we had a car we could rip things out of if we need to, but it might be kind of hard to make sure you're buying the right things that that are compatible. It's kind of confusing to order these parts. And then there's some things that are going to maybe require movement of some kind that if you're on your bench, you're not going to have. And that's why you saw this thing where I was backing up the test bench into my child.
It's hard to test backup sensors when you're stationary, right? It's just difficult to do. So we came up with the solution, our mobile testing platform, which was this, some go-karts that we got to buy online. And Charlie and I thought, wow, we got DARPA to buy us cars. I wonder if we can submit a new grant and get them to buy us go-karts. The answer, everyone, is yes. They did buy us go-karts.
These are very expensive go-karts.
Yeah, these were very expensive go-karts, which we had to build ourselves, which kind of sucked. But
yeah,
I messed mine up. I broke a few bolts off. It was very unsafe.
Yeah, me too. It probably took me a month to build that stupid go-kart.
Yeah. Here's mine. We have seat belts that are non-functional, but generally we have the whole pre-collision system in the front, right? And we have the parking assist and everything in the back. So it's wired the same as the bench, but this time it's on a cart in case we want to test things like movement. I think Charlie can take claim for having the most sophisticated go-kart in the world at one point.
Yes, I think no one would argue with that if you look at this. So yeah, my go-kart had all the internals of the Ford. His was like a Toyota go-kart. Mine was a Ford go-kart.
Yeah.
Mine had like speedometer. Like I said, it had XM radio, which is pretty sweet. It had power steering. It had rear brake sensors. I don't know, other cool stuff I can't even think of. It had what else did it have? I don't know, but anyway, you'll see some of the videos. It's pretty rad.
Yeah. Yeah, I think that's just the overview of my cart there.
There's no video on this one.
I think so,
No,
but I
there
think
is.
it just goes around.
Okay, so here's the go-kart.
Yeah, it just goes over all the systems.
So Chris couldn't get his steering wheel plugged in properly, so he's got 2 steering wheels on his go-kart.
Yeah. Shockingly, a steering column from a Toyota Prius wasn't designed to be linked up with a go-kart. I found that out, funny like that, right? I didn't know, I can't weld, I didn't know any welders because I was just going to break it off, but I decided to have multiple steering wheels.
So one steering wheel drives the actual go-kart, and the other one you can attack.
Yeah, exactly.
But on the Ford, because I know what I'm doing, I have one steering wheel that will actually have power steering and control the go-kart. It's super sweet.
I know. Well, what can I say? You're the man.
Yeah, I'm a good mechanic.
You can have these carts, right? And you have multiple CAN networks, and they can move, and they have sensors. The only thing that we had to add was an external power source, right? It's because it was a car battery. So essentially, you have like a little car to test with.
I almost had the auto parking working on the go-kart, which would have just been the most awesome thing ever.
Yeah. Oh, that would
It's
have
like
been amazing.
more sophisticated than almost every like real car in the world. It would be a go-kart, but I
Exactly.
couldn't quite get it to work. It needed so many sensors.
The pros of it, mobility testing, right? Now anything that requires movement, you have the capability of movement. It kind of taught me at least a little bit about cars and how everything would work and how steering columns are made for a certain vehicle and not go-karts. Lastly, they're badass, man. Driving these things around in the street doing testing was awesome.
Yep.
The cons, though, Charlie.
It was hard to put together. It was, like you said, the car parts don't really fit. Mine was so loaded with car parts you could barely get in it.
Yeah.
And then
There was this other like open source car in a box. You can skip this video. It's just me driving around.
Nah, man, this video is cool.
Yeah. This is a bird's eye view of the go-kart. So you see this is my house, and there's a public road, and this is where I did my testing. So people would just see this crazed maniac with a GoPro driving a go-kart around loaded with car parts, doing testing in the street. In the middle of winter, no less, where there's snow on the ground.
Can we turn the volume up?
I don't know. Yeah.
Will generally work for the most part.
They sound pretty badass, right?
With ease.
They are cool. So if you look, like he's got all these ECUs just duct taped onto
They're
it.
zip tied and duct taped. That's how I put them to the cart. So not
Now
very.
he's going off-road
Yeah.
here.
Now I go over the curb and it knocked like a bunch of stuff out.
Everything kind of holds together.
Everything did work though. I drove it around the block a few times for testing, and you can see there's what used to be the Prius still in the driveway. So yeah, it was cool.
Here's mine. A very short video of me driving mine. You can check out it only drives with the computer simulating traffic, so you can see I have to drive around with the computer on and all my ECUs everywhere.
Now imagine you're in a neighborhood and you see like this guy just with a computer and go-kart on stuff. So we have to look like maniacs the entire time.
Yeah.
Steering. So I did steering in the go-kart here, and we actually figured out something new with the steering is since we were replaying traffic at the wheel angle being 0, we could actually turn using lane keep assist multiple rotations. You'll see the fake steering wheel there turning pretty fluidly, right? So we realized in a real attack, you could try to say the angle's at 0 and lane keep assist should be at angle 5, right? So we actually learned about attacks that we could have done in the car by testing it on the Workbench mobile platform, I should say.
Yeah, so here on the Ford, hopefully it'll fix this up when I play it. I can show you that I actually had the wheels, the speed sensor, like properly wired up to the speedometer and all that kind of stuff. So my go-kart actually had a functioning speedometer.
From a Ford Escape.
Right. It's like shaking apart, and you can see just the jumbled wires. That's my brakes. Anyway, so you can get a bird's eye view of driving around my go-kart in my little town. But like the tachometer works and everything too. It's like pretty awesome. But yeah, you can imagine doing attacks. Like we have an ODB-II port. You could do our same exact attacks we did just against the go-kart.
Again, yeah, you could, if you want to replicate our attacks and not buy a Prius or Escape, spend a couple $1,000. Yeah, both papers will tell you how to do exactly everything we did. You can replicate it, add on to the test, all that stuff.
All right, so what could go wrong? Well, the good thing was it was almost impossible to ruin any of the ECUs. You could send them bad messages, you could not send them messages. They still would. You turn them off, turn them on, they were like as good as new.
Yeah, I think twice I bought new ECUs when I didn't need to because I thought it was broken, or I thought I fried it. It wasn't the case. They're super resilient.
Right. You have to get a baseline capture. You have to buy a mechanics account. So there are some issues, but the main issues is you saw that jumble of wires. Like, it's great when it was working, but all of a sudden something would stop working. It's like, okay, well, it's one of these 5,000 wired connections.
Yeah.
I don't know which one.
I'm sure there are better solutions, but we were just twisting wires. So I'd solder a few of them, but then I was like, nah, just electrical tape. And you'd bump over a curb, and nothing would work, and you'd be in the garage, all night trying to figure out what it did.
So there's just wires everywhere, and like,
more wires.
Here was my workbench.
Charlie's dead. He showed me this picture. I was like, this is the most absurd thing I've ever seen. I don't know how you make heads or tails of any of this.
I mean, it was a lot of taking a wire and running your finger along it until you saw where it went.
If you unplugged one thing, it's like a whole day of debugging.
Yeah, it was awful. And I would prefer to be debugging software, not like wires.
Yeah.
So it was bad.
Yeah.
But when it worked, it was cool.
Have we mentioned wiring? Wiring seemed to be our biggest pitfall of all this. Again, there's an alligator clip came undone, and I spent a day being like, Charlie, my go-kart's broken, it won't work. I have to quit.
I got this call from him about 7 times.
Yeah, I'd always call it a panic. He's like, did you check all the wires? I was like, of course I checked all the wires. And then I didn't. Then I'd go back and check them more.
Like 6 hours later, oh yeah, I found the loose wire.
Yeah.
So if you want an idea of what these ECUs cost if you don't want to buy a car, so the ECM was like $200, transmission ECU 150, TPM 50. So I mean, these things are pretty cheap.
Yeah.
The CPL ECU is kind of expensive for some reason, but you can decide which ones you really care about, and really you care about the ones that have like the remote aspects, so that telemax unit or the head unit or something like that.
And those usually are produced more in mass because people replace those things or whatever. So they're pretty easy to acquire. Again, eBay, Salvage Yard, or official OEM parts retailer is where you can get these things.
All right, so we set out to get people involved in car hacking, and it didn't really work because people weren't willing to ruin their cars. And so we tried to go like one step further and have this research to where people could get into car hacking at least at an introductory level without a car, for a couple $1,000, which is kind of what people spend for IDA Pro anyway.
Yeah.
And so hopefully people will take this, and we have that paper I mentioned, and they can start playing around with stuff and not worry about their wife being mad at them because they wrecked their car.
Exactly. Yeah, we want everyone to build on this, right? We don't want it's not a done complete thing, right?
Right.
Take this information. We're all smart people, but especially for automotive, there's right now a very limited subset of people working on these problems as opposed to web browsers or document readers or malware, right?
Because even though like Chris and I are going to present this like super cool remote attack, that's just against one car, and like we can't look at the 60 or 70 different car models out there. So we need to have more than us doing it.
Exactly. So hopefully this will at least inspire people to take a look at the papers, the 2 papers, kind of a couple hundred pages, and go about doing some testing. Even if you find that, something simple that this head unit has this old version of Bluetooth or something, like that's something you can report and tell someone or talk about at a conference, whatever. Lastly, Gruck, we got 2 cars and 2 go-karts. Suck it, Gruck. You wanted a car, you didn't get one, we got 2.
Your tax dollars at work.
Yeah. All right, cool. That's it. With any questions?
So we all bought you 2 cars and 2 go-karts. Have you approached the automobile manufacturers with this research?
They know about it for sure.
Yeah, we've talked to also the Department of Transportation, Society of Automotive Engineers. So we've had several discussions with them about our research and what we've done and where we're going. So they're very aware of it.
Right. And
What made you start this?
I think we both got tired of just hacking computers.
Right. So some other researchers before us in 2010 and 11 had done remote attacks against like a Chevy Malibu or something. And so we read that paper. I thought it was really cool, one to keep doing. And I guess I should also say the end of this story is that these futuristic, high-powered, advanced go-karts are now like government property in some warehouse somewhere.
We assumed it was like Indiana Jones where they put them in a crate and into some massive warehouse and we never see them again.
Right. But yeah, we don't have them. The government now has those. They also have the Prius and the Ford. So we don't have any of this equipment anymore.
On all the new cars that have the Bluetooth synchronization with your ICOM, come to find out You have to clear the cache on the car, but you have to look it up for the car. There's a whole wealth of information in people's contacts that are running around in rental cars.
Yeah, I was gonna say, do you ever get in a rental car and it's like, oh, I wonder who they called. Here's all their buddies.
Exactly. The other thing is, are you guys going to start working on airplanes?
Oh, I don't know. You
I wish
want to
it-
get me a Boeing and park it out front of my house? That'd be great.
Yeah. I don't think the government really wants to buy us an airplane. but
No.
If they did, I would look at them.
I think they want to know
Yeah.
what you can do, because for these self-assisted parking, the cars park themselves, there's controls of the steering wheel.
Yeah,
all the steering attacks. That's why we bought cars that park themselves.
Right, so both of these cars had auto parking, and that's how we were able to make the steering wheel turn, is using that same sort of technologies. For sure. I mean, in the research we did here before this, we showed like we'd be driving on the road at like 50 miles an hour, and Chris would make the steering wheel yank.
Yeah. We actually wrecked this reporter from Fox News. He was like, hey, I think they're going to turn the steering wheel. And I was typing in the back, and Charles was like, put your hands on the wheel. And he didn't do it. We smashed into a ditch, and the cameraman went flying, and it like turned ghost white. So it's like, it's a very realistic thing that could happen.
Right. For that, we had to be wired in because we didn't have a remote aspect at that time.
Drive anything more than 55 Chevy.
You will not be hacked. in
Yeah.
that.
So I've used these little ODB-II wireless things on my iPhone to diagnose problems with car vehicles. Any chance are you guys building one of those that I can use to feed stuff into the car?
So the one that I had that I started, I never finished, is called OpenXC. You saw a picture at the beginning. It was made by Ford, or it's not made by Ford. Ford had like Android development kit for it that could communicate. You might want to check that out because at least it gives you a head start to all the comms.
Yeah. We also built like OBD2 thing you could plug in that would sort of try to detect attacks and stuff.
Oh, yeah.
On a moral principle, I'm sort of opposed to plugging things into your OBD2 port that have wireless connections,
Yeah.
because that means someone else conceivably could get onto that, and then they could send CAN messages. And so it basically eliminates the first of the 3 steps of the attack, which is like, how do you find a remote bug? It's like, oh, well, this guy plugged something in that accepts wireless communication. So,
Sure.
so be careful when you have those things plugged in, or only plug them in when you're stopped or something.
In the back? It's manufacturer by manufacturer. Some have flat networks where there's no kind of router. Others have centralized ones where it kind of routes everything everywhere. Others have 2 separate networks segregated between 2 routers. There's no standard. It's however they made the car, and whoever made it decides what they do.
Yeah, and if you look up, we did a paper last year at Black Hat where we took all of the manufacturers and we outlined what their architecture of their CAN networks look like, and we sort of rated them on like this one would be the easiest, this one would be the hardest. So yeah, if you're interested, check out that paper. It
Yeah,
says
like
all the
the
different ones.
centralized version that I talked about was like Audi. Basically has this one basically big router thing that routes all the packets everywhere.
Right. And we don't know whether it lets all the packets through or whether it blocks it, but at least it has that functionality. It has that position in the network where it could block traffic.
Yeah, changing software is easy. Hence why they make all these things software. Changing architecture and hardware is hard. So if if you have a flat network and there's no routing, then you can't just add one in after the fact. But if you already have one and it's software based, you can apply an update at the dealership or over the air and fix any problems that might arise. Any more? Awesome. Thanks for having us. Oh, wait. Oh, sorry. Go
One
ahead.
more. This is it. Well, I don't know if you'd even say we hacked them because we required physical access. But of those, we made more progress with the Toyota because it had more advanced features. So the Ford didn't have like lane keep assist.
Yeah.
It didn't have pre-collision system.
And more things were multiplexed in the Toyota, as in it used the CAN network to do more things, where in the Ford it was more hardwired. They still had a lot of wires going around.
Right. Okay. So now you can clap.
All right,
If you
cool.
wish.
Thanks so much.
Thanks.